Started. Hello. Am I audible? Everyone? Hello, students. Good morning. Good morning. Good morning, Manish. Good morning. Good morning. Good morning, Ananya. Good morning. Okay, my voice is coming? Okay, Ananya. Yes. Good morning, Janvi. Good morning, Manish. Yes. Okay, very good. So let us start. Good morning, everyone. So let me wait for a minute. So yesterday was Bakrid. Most of you had some festival. Most of you had very good festival. Muslim people have very good festival yesterday. So good morning, good morning. Yes. Yeah, today we should start again for our aim. Okay. So what are we preparing for? We are preparing for NEET. Every day I start my class with first writing aim NEET 24 here. Why? Because we need to remind ourselves daily that I want to be a doctor. Okay, I want to be a doctor and I will prepare hard for it. It is my aim, so I will work hard for it. Okay, so every one of you be confident that you will be selected. Just work for it. Okay, if you work enough, if you do enough hard work, nobody can stop your selection. Nobody can stop your selection if you do your hard work completely. Okay, so what we were learning in the physics we were learning about the basic maths, and in basic maths we have covered some coordinate geometry, etc. And now we are starting with vectors. In the last class I have covered some part of the vectors. Vectors are physical quantities which require dimensions also, which require directions also to specify them. Vectors are physical quantities which require both magnitude and direction to completely specify them. This kind of quantities are called vectors. Okay, we have learned how to write a vector, how to express a vector. So vector can be expressed graphically using a line segment with arrowhead. We have expressed vector with a line segment with arrowhead. Name of vector is English alphabet with a symbol of vector above the English alphabet. This is how we name the vector. Okay. The length of the line segment gives you the magnitude of vector. The magnitude of vector is written like mod A. This is the length of vector, length or magnitude. So vector has both magnitude and direction. The magnitude of vector is given by the length of the line segment, and the direction is given by the arrowhead. In whichever direction arrow is pointing, that is the direction of vector. Okay, we have covered all these things. Vector can also be expressed in component format. In x, y, z directions. If you take x, y, z direction, then unit vector. I have also covered unit vector. Unit vector is a vector whose magnitude is 1. They are special vector. Unit vector in direction of x-axis is represented by I cap. Unit vector in direction of y-axis is represented by j cap. Unit vector in direction of z-axis is represented by k cap. What are I cap, j cap, k cap? These are unit vectors in direction of x, y, z axis. If I want to represent any vector along x-axis, I can represent that using I cap. To represent any vector, I can write any vector as magnitude of vector into unit vector in the direction of vector. Magnitude of vector into unit vector in the direction of vector. I can write any vector as magnitude of vector into unit vector in direction of vector. Okay. Yes. Hyperbola is 1 y equal to 1 by x. Very good. Yes, sir. Online classes up to we are covering physics now. In physics we are covering vectors. Okay. Now, so any vector can be written like its magnitude into unit vector in its direction. We can represent a vector like this. Okay, so if I want to represent a vector along x-axis, let's say the magnitude of vector is 2 units and it is directed along x-axis. To represent this vector, I can represent this vector as 2 into I cap. How 2 into I cap? The magnitude is 2 unit, it's given here, and the direction is along x-axis. So I can represent this vector as 2 I cap. This is how we represent vector in component format. I have also told you about the component format. Any vector can be written as different components along x, y, z axis. So ax I cap, ay j cap, AZ K cap. Any vector can be written like this. Here I cap, J cap and K cap are written. If I forgot to write cap, please remember cap is already mentioned. Okay. Understand by yourself that cap is there. Okay. Sometime I will forget to write the cap on IJK. Understand that cap is written. Okay. It's a convention. People usually don't write the cap. So if this is the vector in component format, then the magnitude of vector is given by root over ax square plus ay square plus az square. This is the magnitude of vector. And in order to find a unit vector along a cap, you can also use this concept, unit vector along a vector, a cap. That can be written like a vector upon mod n. If I divide a vector by its magnitude, I will get unit vector along direction of a. I will get unit vector in the direction of a. To get the unit vector in direction of a, I will divide a vector, which is ax I cap, ay j cap, az k cap, divided by magnitude of a, which is root over ax square, ay square plus az square. This concept, this equation was told to you in the previous class. I have told you this equation in the previous class, but this is not covered in the previous class. Okay, this is new. So we can write this equation when vector is given in component format. When vector is given in component format, to write unit vector along a vector, if a vector is given in component format, to write unit vector along a vector, we can use this. A vector divided by magnitude gives unit vector in its direction. There are some questions in your gym book. Okay, so use this concept. Is this point understood? Any vector divided by magnitude of that vector gives you unit vector in that direction. Okay. So some questions are there in your gym book, and sometime in physics also we require this. We need to find a vector in particular direction, unit vector in particular direction. So we can find a vector in that direction and divide magnitude of that. Okay. Is this point understood? Everyone, please reply. Is this point clear? Yes. Okay, Manish. Very good. Durga Prasad. Very good. Sahiti. Okay, very good. Very good. Okay. So there is some delay. I think 30-second or 15-second delay is there. So can you give one question from gym book? Yeah, this I can give you one question from gym book. I can give you a question on this concept only. Okay, let's do one question on this concept. Question. Find unit vector along I plus j minus k. Find unit vector along this vector I plus j minus k. Find unit vector in this direction I plus j minus k. Find unit vector along this direction I plus j minus k. Find unit vector along I plus j minus k. A vector is given to you in component format, and I am asking unit vector in this direction. So give me unit vector in this direction. Very easy question. Do it fast. Very good. Kusuma Kumari, very good. Hare Krishna is also correct. Very good, Manish. So it's a very easy question. Vector is known to us. Magnitude can be calculated. Magnitude of this vector. Let us assume this is some vector. Let give this some name. Okay. So I am giving this vector a name P vector. I am assuming this vector is P vector. Let us assume this is P vector. Then the magnitude of P vector is given by root over x component square. So in multiplication of I, whatever is written, that is x component. So nothing is written. That means I will assume that is 1. In multiplication of j, 1 is written. In multiplication of k, minus 1 is written. Okay, so this is multiplication of x square, this is coefficient in y square, this is coefficient in z square. Root over x square plus ay square plus az square. So 1 plus 1 plus 1, I will get root 3 as magnitude. So if I divide this vector by root 3, I will get unit vector in direction of p cap. Unit vector in direction of p vector. Unit vector in direction of p vector. We can represent it by p cap. So p cap will be I plus j minus k. This was p vector divided by magnitude of p vector. Okay. Some people can also divide every ijk by root 3. So they can write this vector like this: 1 by root 3 I, 1 by root 3 j minus 1 by root 3 k. So don't get confused. These two are same. Okay. Okay. Yes. So we have covered all this thing in previous classes. Okay. This point was new today. Okay. Now we will start vector addition. Vector addition. Before learning about vector addition, let's cover one more concept: angle between two vectors. Write down angle between two vectors. Angle between two vectors. Angle between two vectors. Angle between two vectors. Sometimes vectors are arranged and we require the angle between the vectors. A vector is given to you and they will say another vector is at 30-degree angle with this vector. So how to know this angle? Where to take this angle? Angle between two vectors is the angle between the directions of vector. It is angle between directions of vectors. We define angle as angle between directions of vector. If two vectors are arranged either tail by tail like this or head by head, two vectors are arranged such that their tail points are common or head points are common. Tail points are common or head points are common. Two vectors are arranged like this. Okay. Then the angle created between them, which is less than 180, this angle, not this, this is greater than 180. We will not take this angle. We will take this angle, which is less than 180. This is called angle between vector. Similarly here, we will take this angle as angle between vectors. And both are same. Both are same. Okay. Why they are same? Because when these two are arranged head by head, these two angles are same. Okay. If I extend these vectors and I arrange them tail by tail, angle created is same. So angle between two vectors, if that is given by theta, that is always between 0 and 180. And it's the angle between vectors when they are arranged tail by tail or head by head. Okay. Arrange two vectors tail by tail to know the angle between them. Is this point clear? Angle between two vectors is the angle between their directions. So first vector is in this direction, second vector is in this direction. The directions are making theta angle with each other. This is the angle between their directions. Note it down. An angle between vectors can be in between 0 and 180. In which case it will be 0 degree for parallel vectors. If two vectors are parallel, angle between them is 0. In which case it is 180 for anti-parallel vectors. If two vectors are in same direction, we say them they are parallel. If this is your P vector, this is another vector, let's say Q vector, they are parallel. In this situation, we say the angle between them is 0. And if they are anti-parallel, like this, we say the angle between them is pi, 180, pi or 180, anti-parallel. In all other cases, the angle between them is between 0 and 180. So, range of angle between vector is from 0 to 180. Range of angle between vectors is from 0 to 180. Is this point clear? Tell me, is this point clear? Everyone? Should I proceed? Is this motion in plane? No, Harsha. We are learning vectors. Motion in plane is going on simultaneously. But the angle between tail tail and tail or head and head. Both are same. Both are same. Durga Prasad, both are same. Either you arrange two vectors head by head or tail by tail. You get same angle. You get same angle. Okay. So let me give you one question then. I am arranging two vectors. See, this is our A vector and this is our B vector. The angle here they are making is 120 degree. 120 degree. Tell me what is angle between A vector and B vector. Angle between A and B. What is the angle between A and B? This is my question. This is my question. You can see here A vector, B vector. This is 120. I am asking angle between vectors. Okay, Kusuma, very good. Others, this is very easy question. Your answer should come very fast. Very good. Very good, Janvi. Very good, Manish. Very good, Bharat. Durga, very good. Very good, warrior. Okay, everyone is giving correct answer. Very good, very good. बहुत बढ़िया, शानदार. Okay, you can see here A vector and B vector are not arranged here tail by tail. They are not arranged here tail by tail. On the head of A, tail of B is arranged. So in this situation, we cannot give this as the vector. This is the angle between A and B. We need to shift A vector so that they are arranged tail by tail. And I can shift a vector parallel to itself. I can shift a vector without changing its direction. So I can move this vector without changing its direction. So if I take that A vector, because this is the digital board, so I can select the A vector here. Okay, see I am taking A vector and I am shifting it. Can you see I am shifting it parallel to itself? I am taking this A vector and I have shifted it so that now A and B are arranged tail by tail. Yes, they are now arranged tail by tail. Now if I observe the angle between A and B, that is simply 60 degree. To find the angle between two vectors, we need to arrange them first. Okay, or you can learn this point, you can remember this point. From now on, you should remember this point. If two vectors are arranged such that on the head of first, tail of other is arranged. In that case, extend the first vector, then this angle gives you angle between vector. This is the angle between vectors when two vectors are arranged like this. Okay, we need to remember this figure in our mind. When on the head of first, tail of other is arranged, then this is the angle between vectors. If this was given as 150, then this will be 30. Okay, 180 minus this angle will be this. So correct answer of this question is 60. Very good. Very good. Okay, very good. So we have now discussed what is the angle between two vectors. Now we are prepared to learn about the vector addition. Write down vector addition. Vector addition. Vector addition. What is vector addition? Sometime, for an example, if I give you an example, suppose a box is placed here. A box is placed here. We have some chairs or these things here. So this chair, suppose you're going to see there is a chair here. Okay, I need to push the chair. I need to push the chair. Okay, two people are pushing the chair. Suppose this is very heavy and two people are pushing the chair. I am pushing the chair towards you and someone is pushing the chair in this direction. So if we both push the chair, I am pushing the chair towards you and someone is pushing the chair in this direction. So it will go diagonally, isn't it? Simultaneously, two persons are pushing a chair. Two people are pushing a box or chair. One is pushing the box in this direction. Other is pushing the box in this direction. Then by our experience, we know this will go this and this in this direction, isn't it? These are the two push and this is the net movement. Have you seen this kind of situations? You must have seen this kind of situation. Okay, you can try this on your home. Okay, so the direction in which this box is moving finally, that is the direction of their addition. That is the direction of their addition. When we apply two or more forces simultaneously, or in some other situation, two or more displacement, two or more vectors, when two or more vectors are acting simultaneously, the final thing that object does is go in the resultant direction, and that resultant is nothing but addition. Vector addition is nothing but resultant. So when two vectors are added, we get a addition or resultant, which gives the combined effect of vector. Vector addition gives the combined effect, net effect, resultant effect, combined or resultant. So this becomes very important because sometimes in physics we have seen a lot of forces are acting on a body, so we need resultant. And in kinematics also, body may have different displacement, different time. They will ask you what is the net displacement. So in those cases we need the combination of vectors. And how to combine the vectors, how to add the vector, we will learn vector addition in three cases. Vector addition three types. We will first learn how to graphically add the vector. Graphically vector addition we will learn. Then we will learn formula, how to add vectors in formula. Then by formula method, okay. And then last, if vectors are given in component format, then we will learn addition in component format. So we will learn vector addition in three situations. First, we will learn vector addition in graphical way, then formula method, then component format. In graphical way, we will first learn triangle method, triangle law of vector addition. I will start with triangle law of vector addition. Then a slight difference we can do in triangle law, and we will get parallelogram law. Parallelogram law. And if we need to add more than two vectors, we will use polygon law. These two are to add two vectors. These two laws will be used for adding two vectors. And this is for more than two vectors. Okay. So I will start with triangle law of vector addition. Then after that, I will give you the formula, then parallelogram law and polygon law. Okay. This is the order that I will be going. So let us start triangle law of vector addition then. Okay. Triangle law of vector addition. Triangle law of vector addition. Write down triangle law of vector addition. If two vectors are arranged, such that on the head of first vector, this is my first vector, and this is the head of the first vector. This is the tail of the first vector. This is the head of first. I am arranging on the head of first vector tail of my second vector. I have arranged two vectors such that on the head of first, tail of second is arranged. Can you see here? This is my first vector, this is my second vector. The tail of the second vector is on the head of the first vector. If the vectors are arranged like this, I will show you the angle between vectors here also, that is theta. This A vector is going in this direction, this B vector is going in this direction. So angle between the directions here is theta. Okay. So I have arranged two vectors such that on the head of first, tail of other is arranged. In that situation, from the tail of the first to head of the second, from the tail of the first to the head of second, this is the vector addition. This vector, which is from the tail of first to head of second, this gives me the vector addition. This is the sum of the two vectors A and B. We can also write this as R vector. We use R vector to show resultant. Some people will use R vector to show vector addition. I can use A plus B also. Okay. Yes. So to add two vectors, The same topic was teaching in offline also. Yes, yes, very good, Dora. So two vectors, if two vectors are need to be added, two vectors are needed to be added. I will arrange the two vectors such that on the head of first, tail of other is arranged. Then from the tail of first to head of second, this gives me the resultant vector. This vector from the tail of first to head of second, this gives me the resultant. This is the triangle law of vector addition. Why we are saying this is a triangle law of vector addition? You can see here a triangle is formed between A, B, and resultant. Now A vector and B vector, A vector, B vector and R vector are three sides of triangle. Three sides of triangle. There are three sides of triangle. That's why the name of this law is triangle law of vector addition. Why the name is triangle law of vector addition? Because A, B and their addition creates a triangle. Note it down. Triangle law of vector addition. Triangle law of vector addition. Triangle law of vector addition. Two vectors are arranged such that on the head of first, tail of second is arranged. Then triangle law of vector addition gives this side length, third side length as the addition. Okay. This is triangle law of vector addition. Now because they are creating a triangle, so some property of triangle will be followed. Some property of triangle will be followed. Because they are creating a triangle, some property of triangle will be followed. If three vectors are creating a triangle, they must be in same plane. Otherwise, how will they create a triangle? So A, B and R vector resultant are in same plane. R means A plus B, A plus B, A plus B. It means two vectors are in a plane. Two vectors are always in a plane. Okay, I can always arrange two vectors in a plane. The resultant is always in the same plane. This is the first point we are observing here. If two vectors are added, the resultant is also in the same plane. If two vectors are added, the resultant is also in the same plane. If two vectors are added, the resultant is also in the same plane. Wait, Sindhu. Wait. You can ask this type of question to administration people. Okay, here we will learn physics only, and this type of question you can call and ask. Okay, Sindhu. So what the point here? The point here is A and B. If this A and B are added, we will get a resultant which is in the same plane. This is a very important concept. There is a question in your gym book on this concept. So this is very simple and important concept. Note it down properly. Note it down properly. I will give you another important concept here. Another important concept here. See these three lengths, they are triangle. These three lengths, they are triangle. If you see here, this length, and this length, they are creating a triangle. The length of vector is the magnitude of vector. The length of vector is the magnitude of vector. Can you see? This is the magnitude of resultant. This is the magnitude of A vector. This is the magnitude of B vector. Okay, so what I can get here? The length of resultant, this length, that will be less than sum of other two lengths by triangle property. The resultant length, the length of resultant, which is magnitude of resultant, you can also write this as magnitude of A plus B. Magnitude of A plus B. A side of triangle is always less than sum of other two sides. This side length plus this side length. This side length will be mod of A plus this side length will be mod of B. So we are getting a very special property here that the resultant, that is A plus B, will have a magnitude, will have a length which is always less than or maximum can be equal to sum of length in A and B. Sum of length of A and B. Similarly, by triangles property of triangle states that this length will always be greater than difference of these two lengths. Difference of these two lengths. So it is mod A minus mod B. This is triangle inequality. This is triangle inequality. This equation is called triangle inequality. Triangle inequality. What is triangle inequality? When a triangle is created, a side of triangle is always less than sum of other two sides. A side of triangle is always less than sum of length of other two sides, and side of triangle is always greater than some difference of length of other two sides. One side length of triangle is always less than sum of other two length, and it is always greater than difference of other two length. So this is called triangle inequality. What is telling me? This is giving me the sum, the A and B vector sum. This can have maximum value of this, minimum of this. So I am getting maximum minimum range of the addition of two vector. What I am getting? Maximum and minimum range. A vector and B vector, when they are added, the maximum value, the value of this resultant can maximum be equal to sum of A plus B, length of A and B. Okay, and similarly, if I observe the minimum value of sum of A and B, minimum value of sum of A and B, that comes out to be difference in the magnitude. Difference in the magnitude. Difference in the magnitude. So I am getting two special point here. Sum of two vector can have a maximum resultant as the sum of magnitude of A and B, and sum of two vectors have minimum length possible as difference in the length of A and B. Okay, this is very important point. How to get this case? When the maximum value of A plus B will come, that happens when A and B are parallel. If you have A vector and B vector as parallel, that is theta is 0 in between. For this situation, that sum of length of A and B gives you sum of length of resultant, A and B must be parallel. See that in this situation, if I add A and B, if I create a vector from tail of A to head of second, this green color vector shows me the resultant. So it's very easy to see the length of this resultant is equal to length of A plus length of B, isn't it? The length of this R vector is length of A plus length of B, isn't it? The length of the resultant is length of A plus length of B. So how length of resultant is sum of length of A and B when theta is 0. This is a special case. See this, is this point clear? The maximum length of resultant can be obtained when A and B are parallel. Okay, or of course it's very easy to see when two vectors are arranged in same direction, we get maximum possible resultant. In practical life also, you have seen, if you want to push a car, yes, I am saying this again, if you want to push a car, two persons are pushing a car. If they push the car in same direction, then you get the maximum possible movement of the car. But if they push in car in opposite direction, you get a minimum possible motion in the car. Okay, but you push the car in different directions, then you will not get maximum motion of the car. To get the maximum resultant, the two vectors must be in same direction. And I am arranging, yes, I am saying this again, I am arranging the vector such that on the tail of head of first, tail of second is arranged. In that case, from the tail of first to head of second, this is my resultant. And can you see here, this total length is length of A plus length of B. Is this point clear? Length of A plus length of B giving you length of the resultant is A plus B. So this is possible when theta is 0. This situation is possible when theta is 0. This is possible when theta is 0. Okay. And the other situation is possible when theta is 180. Let me draw that figure here. If this is your A vector, on the head of A, I am arranging tail of B. On the head of A, I am arranging tail of B. They are anti-parallel. Here theta is pi or 180. They are anti-parallel. Now, the addition of A and B is from tail of the first to head of second. This is the addition. And can you see this length can be written as length of A minus length of B? length of A, this total length of A minus this length, this total length minus this length gives you length of R. So length of resultant is length of A minus length of B. When theta is 180. This is happening when theta is 180. When two vectors are parallel, we get maximum possible resultant. When two vectors are anti-parallel, we get minimum possible resultant. When two vectors are parallel, we get maximum possible resultant. When two vectors are anti-parallel, we get minimum possible resultant. So the resultant of A and B can have maximum value as sum of length in A and B and minimum value as difference in length of A and B. Note it down properly. Note it down. We have discussed here about the maximum value of sum of A plus B, which is sum of the lengths of A and B, and minimum value of A and B, A plus B, that is difference in length of A and B. Okay? I hope this point is now clear, 100%. Very good. So I will give you a question on this concept. Okay? I will give you a question on this concept then. Write down. Write down. Which of these cannot be magnitude of sum of A vector having magnitude 3 unit and B vector having magnitude 6 units? Write down the question properly. My question here is, which of these, I have given you 4 options. I am asking which of these cannot be, right? Remember this, I am asking cannot be. Which of these cannot be magnitude of sum of A and B? Which of this option cannot be the sum of A and B? Cannot be. Cannot be. Okay, a lot of people are giving me correct answer. Very good. Very good. Cannot be. Very good. Which of this option is not possible as the sum of A and B? Two vectors 3 and 6 units are added. 3 and 6 units are added. The maximum of that resulted, which I can get, is sum of the magnitude of 3 and 6. Sum of the magnitude is 9. So maximum is 9. Maximum value of A plus B can be 9 when the vectors are parallel. And minimum can be difference. Minimum can be difference. Difference here is 3. So by our understanding in the previous section, we have understood that the sum of A plus B can have maximum value as sum of the magnitude, difference as 3. So the addition can be in range 3 to 9. We have just learned this thing here. This is triangle inequality, this point. The addition of two vectors can have maximum value as sum of A and B, minimum as difference of A and B. Yes? So my answer can be in between 9 and 3. But in the question they are asking cannot be. So cannot be. Which of this option is not possible? You can easily see magnitude 2 is not possible. Magnitude 4 is not possible. Because they are not possible, I will choose these options. This is my correct answer. This is my correct answer. Answer is 1 and 4. 1 and 4th option. Is this point clear? Everyone? When two vectors are added, the maximum value that I can get is the sum of magnitude. Minimum that I can get is the difference of magnitude. Very good. So we are learning vector addition. In vector addition, I have discussed about the triangle inequality. I have discussed about 2 points till now. 2 points. First point was the resultant is in same plane of A and B. And second point is triangle inequality. In triangle inequality, we have discussed the maximum resultant and minimum resultant. The maximum resultant is obtained when the theta is 0 and minimum resultant is obtained when theta is 180. Okay. Now, if theta is 90, we'll discuss about a simple situation then. If theta is 90, then what will happen? Third point. If two vectors are at 90 degree to each other, I am arranging two vectors at 90 degree to each other. These are two vectors. This is my first vector. This is my second vector. On the head of first, tail of the second is arranged. Then the resultant is given by from the tail of first to head of second. This is the resultant. This is the resultant. And because the angle here between A and B is 90, so we can use Pythagoras theorem to find resultant. The magnitude of resultant here can be written as root over magnitude of A square plus magnitude of B square. How? By Pythagoras theorem. Is this point clear? By Pythagoras theorem, I can get the resultant magnitude if the theta is 90. Tell me, is this point clear? When theta is 90, by Pythagoras theorem, we can easily get magnitude of resultant. Okay? Now, and if in this situation, let's say the two vectors have same magnitude, a special case in this case, if mod of A equal to mod of B equal to let's say x, both have magnitude x and theta is 90, then magnitude of A plus B will be, the length of resultant will be, these two are having same length, x and x, so I will get root 2x. If A and B have same length, x and x, so resultant will be root 2x. Magnitude of resultant will be root 2x. Clear? Why root 2x? X square plus x square, 2x square, root of 2x square is root 2x. Tell me, is this point understood? Everyone? Addition of two perpendicular vector. We can use Pythagoras theorem. Very good, Sharanya. Okay, very good. Now, so we have understood addition of two vector when theta is 0. We have understood when theta is 90, 180. Three situations are covered. Theta 0, theta 180, theta 90. Okay. But what will happen for general situation, general angle theta? Now we will discuss the formula. We'll discuss the formula. When two vectors are added, I will give you a formula to find the magnitude of resultant. I will give you the formula to get the magnitude of resultant. If this is A vector, I am assuming the magnitude of first vector is, let's say, small a. The magnitude of second vector is, let's say, small b. And the angle between vectors is theta. Angle between vectors is theta. Can you see? If I take the direction of A, direction of B, the angle between the directions is here. It is theta. This is theta. What is theta? Theta is angle between the vectors. If I know these three things, magnitude of A, magnitude of B, and angle between A and B, theta, then I can get the resultant's magnitude. I can find the magnitude of this resultant using a trigonometric property. This resultant, or A plus B, the magnitude of this resultant can be easily understood. See here, the magnitude of A is small a. Magnitude of A is small a. I am giving the magnitude of A is small a. Magnitude of this B vector is small b. So this length is B. Magnitude of B vector is small b. This was your B vector and length is B. Length is B. Okay. Drop a perpendicular from here to here. Extend the A vector. Drop a perpendicular from head of B vector. This is 90 degree. This is 90 degree. This is 90 degree. Sir, one doubt, where should I do questions on practice? Gym book, simple. You can solve gym material, okay, for practice. Okay. Now, see, this is a right angle triangle. This is a right angle triangle. Please now understand this is a right angle triangle. In front of 90, this is hypotenuse. In front of 90, this is hypotenuse. In front of theta, this will be called perpendicular. In front of theta, this is called perpendicular. So perpendicular, yeah, that is also okay, King. Please pay attention here. Okay. What we are learning, please pay attention. Otherwise, this will go and you will not understand physics then. Okay. Right. At one time, if we are understanding something, please pay attention to that only. Okay. This length is B. This angle is theta. This is a right angle triangle. So in front of theta, this is called perpendicular, and perpendicular can be written as hypotenuse into sine theta. Perpendicular is hypotenuse into sine theta. Base is hypotenuse into cos theta. We have covered this in basic mathematics. Perpendicular is hypotenuse into cos sine theta. Base is hypotenuse into cos theta. So B into cos theta gives me base. B into sine theta gives me perpendicular. Always remember, in right angle triangle, if you have hypotenuse and theta, then perpendicular is h sine theta by definition of sine theta, and base is h cos theta. Okay. In front of theta, the side length is h sine theta. Along the theta, the side length is h cos theta. Very good. So this is B cos theta, this is B sin theta. Now total length here, can you see? Total length here is A plus B cos theta. Total length is A plus B cos theta here. Okay. And this length is B sin theta. Now try to observe the triangle. This triangle, let's say this is P. For example, this is P. This is Q. This is, let's say, small r. Observe this PQR triangle. This is 90 degree. You know the total base length. This is the total base length. You know the height. This is the height. The perpendicular. Then this is hypotenuse. The magnitude of R vector is hypotenuse. So magnitude of R, which is hypotenuse, can be written as root over base square A plus B cos theta square plus perpendicular square, which is B sin theta square. Isn't it? I am using just Pythagoras theorem. By Pythagoras theorem, the hypotenuse can be written as root over base square plus perpendicular square. Root over base square plus perpendicular square. Okay? If I solve this a little bit, so after solving, I'm not showing you the steps. You can do the steps on your own. Okay, I will not show you the step. I will write down the final formula. So final formula will become root over a square plus b square plus 2ab cos theta. This is the final formula to find the resultant, magnitude of resultant between A and B. Magnitude of resultant between A and B is root over a square plus b square plus 2ab cos theta. Root over a square plus b square plus 2ab cos theta. You need to memorize this. Okay. Note it fast. Note down everything. What we have covered? We have covered how to find the magnitude of resultant using formula method. We have discussed the formula method. Okay. Module enough? Yes. Module enough. Okay, everyone noted? Very good. Please see what we have covered. Very good. Sometimes knowing the magnitude of vector is not enough, because vector is both magnitude and direction. Only magnitude, we do not know vector completely. If we want to know vector completely, we also need to give its direction. We also need to know its direction. So how can we find direction? See, this angle can be calculated. This is my A vector, this is my resultant. The angle between A and resultant, let's say this is alpha. The resultant is making some angle with A vector. I am assuming that to be alpha. The resultant is making some angle with B vector. I am assuming that to be beta. I can give you a formula for A and B, alpha and beta. I can give you the formula for alpha and beta. Now I will give you formula for alpha and beta. The value of tan alpha, a right angle triangle was created there. So value of tan alpha you can easily calculate. Value of tan alpha. See, this is this is alpha. So in front of alpha, this is perpendicular, which is B sin theta. Along the alpha, this is base, which is A plus B cos theta. So by simple tan alpha formula, perpendicular by hypotenuse, I can write B sin theta by A plus B cos theta. This is the formula for tan alpha. This is the formula for tan alpha. And if I know tan alpha, I can give you alpha. Alpha will be, can be written as tan inverse of B sin theta upon A plus B cos theta. So if you know the magnitude of A and B and angle between A and B, theta and A and B, we know this. So using that, we can give you the direction of resultant with A vector. Angle of resultant with A vector. What is this? Angle of A plus B vector with A vector. And similarly, now you need to think on yourself how to get the beta. I will give you the formula. Formula is simple. Just need to interchange A and B. B to A and A to B. Interchange A and B. You will get now angle with B vector. This is angle of A plus B with B vector. Note it down. Angle of resultant with A vector or B vector. If I want to know angle with A vector, I will use tan inverse. I need to know angle with A vector, so I will start with B. In numerator, there will be B. Knowing angle from A vector, I will start from B. B sin theta upon A plus B cos theta. I want to know angle from B, I will start with A. A sin theta upon B plus A cos theta. Okay. I want to know angle with A, then component of B is taken. I want to know angle of B, then component of A is taken. Note it down. These are angles of resultant with A and B. Okay. And we also need to tell sometime with which vector the angle will be more. With which vector angle will be more. So the angle will be more with vector whose magnitude is less. We can write this. Alpha will be greater than beta. Alpha is angle with A. It will be more than beta if A is less than B. And beta will be greater than alpha. Inverse will happen if here inverse is happening. B is less than A. Okay. Angle will be small with vector of larger magnitude. Angle is small with vector of larger magnitude. Okay, you can understand this by drawing diagram. If in A and B, vectors have different length. Vectors have different length. See, I am drawing a vector of large length, then I am drawing a vector of small length. I am drawing a vector of large length, then I am drawing a vector of small length. Now, if I draw the resultant, you can see easily this angle is small than this. Okay, this alpha and beta, if you compare, alpha is smaller than beta because length of A is greater than length of B. So by this diagram, we can understand if length of vector is more, the resultant will be towards it more because its effect will be more. So direction will be more nearer to that vector. If suppose two persons are pushing a car, one is applying more force than the other, then of course the person who is pushing the car with greater force, car will move in that direction largely. That's why the angle will be small with that direction. Okay. So beta angle, can you explain once more? I have told you to calculate beta angle on your own. You need to find beta on your own. The formula is just interchange version. See, here B sin theta, here A sin theta. So A and B are just interchange. Okay, and you can find beta on your own. Just think about extending this line and dropping a perpendicular here. Extend this line and dropping a perpendicular here. Then you can easily find beta. Okay, and you need to find beta on your own. Okay, I am giving you the formula only. I have given you alpha, so you can think of beta on your own. Okay, so what we have covered here, the angle of resultant is less with vector of large magnitude. Note it down. Is this point clear or not? Tell me. Angle of resultant is less with vector of large magnitude. Understood? Very good. So what will happen if vectors have same magnitude? A is small than B, then alpha is greater than beta. Okay, more the magnitude, less the angle. More the magnitude, less the angle. But what will happen? What will happen? Wait. The class is still 10:15. Okay. So what will happen when the angle between A and B is same? What will happen when angle between A and B is same? Next point. What will happen when magnitude of A and B is same? Sorry. Addition of two equal magnitude vector. Addition of A vector equal to B vector equal to, let's say, A. Let's say the magnitude of two vectors is same. In that situation, the magnitude of resultant will be root over A square plus 2A into cos of theta. This formula should be used. Root over A square plus B square plus 2AB cos theta. Instead of B, I am writing A because magnitude is same. So when two vectors of same magnitudes are added, I have two vectors, A vector and B vector, which have same length, A and A. Then the resultant is a long angle bisector. A long angle bisector. It will be a long angle bisector. Why? Because the vector resultant is making same angle with both A and B. Magnitude is same, so angle will be same. If the total angle here is theta, the angle of resultant with two vectors will be theta by 2. And what will be the magnitude of resultant? See, we can solve this equation. A square plus A square, 2A square, this is also 2A square. I can take 2A square common. So 2A, let us solve this step by step. Just a minute. Okay. A square plus A square is 2A square. 2A square into cos theta. I can take 2A square common inside. I will get 1 plus cos theta. Now value of 1 plus cos theta, this is a formula. 1 plus cos theta is 2 cos square theta by 2. We can use this formula. 1 plus cos theta is 2 cos square theta by 2. So this becomes 2A square into 2 cos square theta by 2. So 2 into 2, 4. Root of 4, 2. I can take root now. A square root is A and cos square theta by 2 root is cos theta by 2. So addition of vectors of same magnitude gives me resultant 2A cos theta by 2. Gives me the resultant of magnitude 2A cos theta by 2. This resultant has a magnitude 2A cos theta by 2. 2A cos theta by 2. Two vectors have same magnitude. The resultant has a magnitude 2A cos theta by 2. What is theta here? Theta is angle between vectors. Where is the resultant? Resultant along angle bisector. Note these properties. This is the magnitude of resultant of addition of vectors of equal magnitude. By adding two vectors of same magnitude A, I get a vector of magnitude 2A cos theta by 2. Sometime a question is asked, if I add two unit vector and I get a unit vector, what is the angle? They ask you the angle. They give you vectors are unit vector and ask you the angle. They will give vectors are unit vector and ask you the angle. Find angle between vectors if magnitude of first equal to magnitude of second equal to magnitude of resultant. All three have same magnitude. These two are unit and resultant is also unit vector. All three have same magnitude. All three have same magnitude. We need to find angle. So when the vectors have same magnitude, the resultant is 2a cos theta by 2. And they are saying this is also having same magnitude. I am assuming magnitude is same. Magnitude of A, magnitude of B, magnitude of R, all are same. A. Yes, so we can find this equation then. We can solve this equation. A and A are cancelled. So I will get cos theta by 2 as half. That is cos 60. Okay, cos theta by 2 equal to cos 60. So theta by 2 is 60 or theta is 120. I can take this 2 here. Theta now is 120. So this is a very simple situation of equilateral triangle. Two vectors have same magnitude. This length is A, this length is A. Resultant is also having same magnitude. This is possible when the triangle is equilateral. Of course, three vectors are creating equilateral. Three vectors are creating a triangle. But if the lengths are same, the triangle will be equilateral. Now the angle between A and B is this angle, that is 120. Okay. So when two vectors are of same magnitude and the resultant is also of same magnitude, the angle between vectors is 120 and now they create an equilateral triangle, a special situation of vector addition. Okay, remember this formula, this result. Okay, sometime they will ask you difference also. So today we have covered vector addition only. After next class we will cover difference also. Okay. So today we have discussed about triangle law of vector addition. I have told you the formula method also to add the vectors. Parallelogram law, polygon law, this will be covered in the next class. Okay. QR code. I have not generated my QR code yet. Okay. So wait. Okay. Thank you all of you. So let's meet in next class then. Time is over now. Thank you. Thank you everyone. Bye. Take care.